Students, we have studied about acceleration due to gravity in class 9. We know when a body is allowed to fall freely, the body will be attracted towards the earth. The force of attraction given out by the earth or planets on all bodies lying on or near its surface is called the force of gravity. When a body is released from our hand, the body falls vertically downwards. Why does the body fall towards the earth? Why is it not moving upwards? Have you ever thought about this? It was Isaac Newton who first concluded that the earth attracts every object towards its center. He concluded that when a body is released, it falls towards the earth due to the attraction between the body and the earth. But later on, he concluded that not only the earth, but every body in this universe attracts another body towards it. When a stone is released, not only the earth, but the stone also attracts the earth. Thus, there exists an attraction between any two bodies in this universe. This force of attraction is called the force of gravitation. The moon moves around the earth, and the earth, including other planets, revolve around the sun in their fixed orbit due to this force of gravitation. Now let us learn Newton's law of gravitation. Students, the universal law of attraction between two objects was given by Newton in 1687, which is known as Newton's law of gravitation. The law states every body in this universe attracts the other body with a force which is, number one, directly proportional to the product of two masses, and number two, inversely proportional to the square of the distance between their centers. Now consider two bodies of masses m1 and m2, which are at a distance r. If F is the force of attraction between them, then F is directly proportional to the product of their masses, that is, m1 multiplied by m2. And according to the second statement, the force is inversely proportional to the square of the distances between their centers. That is, F is inversely proportional to 1 divided by r square. Now let us combine equation number 1 and equation number 2. Then we get F is proportional to m1 multiplied by m2 divided by r square, or F is equal to g multiplied by m1 multiplied by m2 divided by r square. Let this be the third equation. Here, g is a universal gravitational constant. Definition of g, or the gravitational constant. Students, if m1 is equal to m2, which is equal to 1 unit, r is equal to 1 unit, then g is equal to F. Hence, gravitational constant g is defined as the force of attraction between two bodies of unit masses placed at unit distance apart. The value and unit of g. In the MKS system, m1 and m2 are measured in kg, r is measured in meter, and F in Newton. So the unit of g is equal to Newton meter square per kg square. Therefore, G is equal to 6.67 multiplied by 10 to the power minus 11 Newton meter square per kg square. The consequences of gravitational force. Number 1, atmosphere on planet is due to gravitational force. Number 2, the earth revolves around the sun in uniform circular motion due to the presence of gravitational force between them. Number 3, tides in sea are due to gravitational force of the sun and the moon on the surface of the sea. Number 4, the existence of the solar system is due to the gravitational force. Number 5, the gravitational force of the earth keeps us firmly on the ground. Now, gravity. Dear students, we know our earth is round in shape. We all are attracted by the earth towards its center. The position of a person in our country and the position of a person in the United States of America is shown in the figure. The main reason behind it is due to the attraction of the earth on the both persons towards its center. Students, earth attracts everything towards its center. Due to this, everything has its own weight. The weight of a body is the measurement of the force with which the earth attracts the body towards its center. This force is called the gravity. We can find the gravity of a planet or a satellite using Newton's law of gravitation. That is, we have the formula F is equal to capital G multiplied by capital M multiplied by small m divided by capital R square. We know this force produces weight on the body, and hence it is also known as the force of gravity. Therefore, force of gravity denoted by W is equal to the product of G capital M and small m divided by R square, where capital M stands for mass of planet, small m denotes mass of the body, R denotes radius of the planet, and capital G is the universal gravitational constant. Students, this shows that gravity of a planet depends upon the mass and the radius of the planet. The moon has its own gravity similar to the earth. The gravity of the moon is 1/6 the gravity of the earth. Thus, a person who jumps 1 meter on the surface of the earth can jump 6 meters on the surface of the moon. If a person can lift 100 kilograms on the surface of the earth, he can lift 600 kilograms on the moon. The mass of Jupiter is about 320 times greater than the earth. Thus, the gravity of Jupiter is about 2.5 times more than the gravity of the earth. Dear students, the space surrounding a planet in which its gravitational force of attraction can be experienced is called its gravitational field. The gravitational field of a planet depends upon its mass. Thus, a larger planet has greater gravitational field. If a body is introduced in the gravitational field, the gravitational force of attraction acts on the body. The gravitational field intensity of a planet at a point in its gravitational field is defined as the force experienced by unit mass, that is 1 kilogram at that point. Thus, by definition, we can write gravitational field intensity, denoted by capital I, is equal to capital F divided by small m, where F denotes the force of attraction on the body of mass m. But we have F is equal to the product of G, m and m divided by r square. So from the definition, we can write I is equal to the product of G and m divided by r square. Students, if m is the mass of the earth, in which a body of unit mass is kept at its surface of radius r, that is, r is equal to the capital R, thus I is equal to the product of Gm divided by r square. Let this be equation number 1. But we know that G, or gravity, is equal to the product of Gm divided by r square. Let this be equation number 2. Now from equation 1 and 2, we get I is equal to G. Thus the intensity of gravitational field due to the earth is approximately equal to the acceleration due to gravity at the surface of the earth. We can use the gravitational field intensity of a planet at a point to find the weight of a body at that point. That is, weight of a body is equal to mass multiplied by gravitational field intensity. Unit, it is expressed in the unit of Newton per kg. The gravitational field intensity of a planet does not remain the same in all places. It decreases with the increase of distance from the planet. Students, we have the relation gravitational field intensity is equal to G multiplied by m divided by r square. Therefore, gravitational field intensity is proportional to 1 divided by r square, since G and m are constant terms. For example, the variation of the gravitational field intensity from the surface of the earth to the surface of the moon is shown. Students, in figure, gravitational field intensity at a distance equal to the radius of the earth from the center of the earth is equal to 9.8 Newton per kg. The gravitational field intensity at a distance twice the radius of the earth, that is at twice r, is equal to 2.5 Newton per kg. Similarly, the gravitational field intensity at a distance thrice the radius of the earth, that is at 3r, is equal to 1.1 Newton per kg. And at the axis of the moon, it is 0.16 Newton per kg. Now, can you tell the weight of the object of 1 kg mass on the moon? It is 0.16 Newton. Students, the mass of the Jupiter is 319 times that of the Earth. But the gravitational field intensity is 25 Newton per kg, which is 2.5 times greater than the gravitational field intensity of the Earth, which is 9.8 Newton per kg. Can you explain it? Although the mass of Jupiter is 319 times of the Earth, the radius of Jupiter is 11 times that of the Earth. Hence, due to this reason, there is no significant increase in the gravitational field intensity of Jupiter. Students, suppose a boy is standing inside an elevator carrying a ball. The elevator is falling freely under the action of gravity. That is, acceleration is equal to g. When the boy allows the ball to fall inside the elevator, what does he find? The ball never falls to the floor of the elevator. It remains suspended in the air. The gravity does not affect the ball. In this case, the elevator, the boy, and the ball are falling freely with the acceleration equal to gravity, that is g. Students, suppose the mass of the boy is equal to m. Now, when he stands on the surface of the elevator, it gives a reaction r in the upward direction. When the lift comes downward with an acceleration a, then mg minus r is equal to ma. Or, from this relation, r is equal to mg minus ma. Or, r is equal to m multiplied by, within brackets, g minus a. Students, when the lift or the elevator falls freely under the gravity, so that a is equal to g, then the apparent weight r is equal to m multiplied by g minus g, which is equal to 0. Thus, the boy inside the elevator finds himself in a zero gravity condition, and thus will be in a state of weightlessness. Students, when a spaceship revolves around the Earth in a circular orbit, the astronauts feel weightlessness, although the force of gravity of the Earth is still quite strong. If an object is left in the middle of the satellite, it will neither fall nor move up, but will remain suspended. Dear students, this is because the gravitational pull of the Earth on the spaceship is just equal to the centripetal force required to move the spaceship on its circular orbit. It is to be noted that when a body moves in a circular path, force is required to keep the body in its orbit. This force is called centripetal force. It always acts towards the center. When the spaceship moves in its orbit, the acceleration of the spaceship and astronauts are both equal to the acceleration due to gravity, that is g of that place. Now, in the other condition, when the spaceship is in outer space away from the Earth's gravitational field, then there is no acceleration due to gravity, and the weight of the body is altogether 0. Thus, the astronauts feel the sensation of weightlessness. Now, do you understand the reason for weightlessness in space? Students, the Earth is not perfectly spherical in shape. It is flattened at the poles and bulges out at the equator. So the equatorial radius of the Earth is greater than its polar radius. Now, since we know that g is equal to g multiplied by m divided by r square, therefore, g is proportional to 1 by r square. Since we know that g and m are constants. Students, this shows that the value of g is inversely proportional to the square of the radius. Number 1, as the value of R is greater at the equator, the value of G is the least at the equator. And number 2, as the value of R is less at the poles, the value of G is the greatest at the poles. Experimentally, it has been found out that at the poles, the value of G is equal to 9.83 meter per second square, and the value at the equator is 9.78 meter per second square. Dear students, now let us find out the value of G according to the altitude. Students, the places at high altitude are far from the center of the earth. Suppose a mountain peak is at a height h. Then the total distance from the center of the earth is equal to r plus h. The place at a low altitude is the one nearer to the center of the earth. Here, h is equal to 0. Then the distance from the center of the earth is equal to r plus 0, which is equal to r. Therefore, here G is proportional to 1 divided by r square. But at the mountain, the distance from the center of the earth is equal to r plus h. Then G will be proportional to 1 divided by r plus h whole square. Dear students, at a high mountain, G is low, whereas at the sea level, the value of G is high. Thus, G decreases with altitude.
G maximum क्या होता है? G maximum क्या होता है?
Altitude.
हाँ?
Altitude.
Sea level में G ज़्यादा होता है कि mountain में? G का value.
Gravity का? तो sea level में.
Now, let us perform an activity. Take a thick plastic sheet and cut it in the form of a circle of radius 20 centimeters. At the edge of the sheet, make small holes at equal distance. Now tie small threads of 15 centimeter in length at each hole. Collect all the edges of the threads and tie a small stone on it as shown in the figure. Now your parachute is ready. Drop the parachute from the veranda of the first floor of your house or school. Students, why does the parachute fall down? Is it free fall?